All right, so we'll be getting started right now. Thank you everyone for joining in. And I am Samuel Bangola, a beta student ambassador, Microsoft Learn student ambassador. And joining me today is Ivan, a payment fraud and reporting lead at Bumble. He will introduce himself much better than I have now. And for today, we'll be talking about leveraging data to mitigate online payment fraud. So I want to do justice to the domain knowledge part. And the first section will be by Ivan on exploring the journey of a payment fraud expertise with him and how he gained domain expertise in preventing and mitigating payment fraud by working with data. And just after him, I'll take a session on leveraging Azure Automated Machine Learning to build and deploy an online payment fraud detection model. I think someone is.
Yeah.
All right. So yes. I hope I'm audible. Can someone just okay, Ivan, can you hear me, bro?
Yeah. Not really.
All right. Not really. Okay, let me switch. Give me a second.
Okay, can you hear me clearly now? Hello? Yes. Okay, it's much better now.
Yeah, actually it is.
Oh, okay. All right then. Yes, I think Ivan can go on now. You can share your screen and we'll get started from there.
Yeah, sure. Let me know if you see my screen.
Yes, I can. It's clear.
Cool. Yeah. First of all, hi everyone. Thank you for inviting me. It is actually a pleasure to do presentation today, and I'm glad that I'm able to discuss about my favorite topics about payment fraud, and we're gonna touch about the data part as well in that presentation. If you have any questions during the presentation before QA session, you can send them in the chat, and I definitely gonna answer them in QA session. If you have later on any questions, still you can send them in the chat, and I'm more than happy to answer on them. Yeah, let me click this button. About myself a bit, not gonna spend a lot of time. So my name is Ivan. I'm in fraud prevention industry about 11 years, almost 12. I worked in a brand like Tinkoff, Forex Club, Get Taxi, Booking.com. My main domain was payment fraud. However, I spent a lot of the times on the different types of fraud as well. And in my own journey for these 11 years, more than half I worked with the data. And later today in presentation, I'm going to show what actually means fraud and data and why it's important to work with the data. And now I'm in Bumble. Who's not familiar with the Bumble? Bumble is dating application that allow people to connect to each other. And there are also a payment fraud part. But I'm going to start from the simple questions, and I'm going to ask everyone who wants to send a quick answer in the chat why we should be aware of payment fraud. Maybe some ideas. If someone wants to say it out loud, please go ahead. It's not a problem.
Okay, can I go ahead and say something, Ivan?
Yeah, please.
Okay, so I feel payment fraud is something that's becoming very popular now, most especially as um, payments transactions are being digitized. So it's much more easier, or I mean, it's more rampant now that these activities go on. So it's necessary for us to be aware that they exist and find a way to reduce them, because physical transactions are less prone to fraud, maybe just theft. But then it being digitized makes it prone to fraud.
Yeah, and it is great answer. And just simplest answer is the company does not like to lose money, like as everyone. And the second point, that's right now, based on statistics, average 3 payment methods per person worldwide right now exist. So when we look on the population, each of us have at least 3 payment methods. You can buy something online. It's even a couple credit cards and maybe some PayPal accounts or any other payment methods. So since we have so many methods how to buy something, that means it's great areas for the fraudsters to stolen this money from our accounts and credit cards as well. But just go show to some numbers. So first of all, it's first data from past year, 2022. And the first number is 5 trillion USD. And it's actually retail e-commerce sales, like stunning 5 trillions happens last year. And this is, I want to be clear, not from all countries. This is actually statistics about mainly countries which operated in US dollars. However, my expectation that if we compare all worldwide transactions, it's going to be much more higher. However, for 2026, it's going to be 8 trillion like USD. It's a huge amount. I would love to have this salary. However, this is only sales for retail e-commerce. And when we're speaking about like cross-border purchase, what I mean here, that if you buy something, for example, I want to buy something from Australia. That means I pay with my credit cards, which is issued in United Kingdom, and I buy something in Australia. That means I have a cross-border purchase, and that's hit 76%. Just for statistics purpose, in 2019, just like 4 years from now, it was 69%. You can see it's like significant increase, like for 7% just for 4 years. It's increasing very high and become more and more popular. People are more happy to buy something outside of their country. People more happy to waiting for delivery a bit more. That's everything that happens right now, and 76% is our new number. I know right now pre-estimated for 2025 at like 82%. So we can see it continue growing. Why it is important? These statistics affirm that online shopping is not passing trend. As consumers to continue pay like online and pay something outside of their country, so it's become more and more popular worldwide. When we're speaking about like payment fraud, it's also I have some numbers here. So 70 billion USD was payment fraud in 2017. That's majority credit cards, and majority of the firms right now calculating the payment fraud based on the credit cards and the banks as well, and what's information shared by banks. I would say it is a bit more if you include additional payment methods and for credit cards as well, because the period when you can set up a chargebacks, which is one of the points how to escalate that you can't recognize purchase, can take up to half a year. So keep in mind this amount is more like transition, and in 2017 it was 70 billions. just what this amount presents is like 10.5 million iPhones 14 Pro. So in 2022, it's right now 41 billion. Like not right now, it's in the past year. You can see increase on 141%. That's again, it's continue to show that payment fraud is some really hot topics, and everyone realized that's okay. We have a problem with payment fraud. Maybe we start to do something with that. And for 2023, expectation like 48 billions USD. That's also a significant amount. I would say it may be hit even higher. It depends how the market continue growing, or if it's something else happens in the world. And even this number is lower because it might be even more if we didn't have COVID. However, COVID had increased number of e-commerce payments as well. Something about like fraud industry. So while the tech industry experienced the job cuts, you might see a lot of the announcements from Monk companies, like from Meta or Amazon, that they cut a lot of jobs, like 10,000 people like was fired because of the cuts that's announced by these companies. However, it's not something that we see in the fraud industry. As you can see on the chart, it's some breakdown by countries. And for example, like Mexico, Brazil, the expectation for this year are higher on 20% more than they expected in the past year. And this is in the fraud industry. What I mean under the fraud industry, it's mean all positions started from like fraud analyst, some manual review specialist, product manager, chargeback team, machine learning data scientist, backend developer, or business analyst as well. But for a while, less than 3% of the merchants are expected to downsize the fraud team, like departments, mostly because they might hire so much in the past years. But when I spoke with people from different countries in different departments, no one expecting any cuts from fraud, because a lot of the companies realize that it's an area where they can save money. How are we preventing fraud, and do we need actually machine learning? That's going to be discussion later on today. Okay, so it's actually plenty of options how we can prevent payment fraud. So it's one of the options in-house fraud solution. I'm going to touch about this one in a couple of minutes. We have a lot of payment fraud providers that guarantee high acceptance rates and low fraud rate declines. So these well-known companies, and they actually they decrease their prices right now because it's a very competitive market nowadays. For example, 7 years ago, it was like 1 or 2 solutions. Right now, it's more than 20. And everyone tried to get this piece of cake to get more and more clients, huge clients, to save money. External solutions that's not only focusing on payment fraud, they're also preventing all types of fraud that can exist on your platform. It's also a possibility to do refunds. That's not actually 100% give you the ability to not getting chargebacks. However, it's also options here. It's one of the ongoing topics, this 3D Secure, or you might hear about SCA, Strong Customer Authentications. That happens when we are asking customers to enter like some digit code or confirm payments in their bank application. It is very popular nowadays, prevention part of the work. However, when you're sending someone on additional step, you're expecting the drop of authorization. That means you can expect less money and revenue on your account. And the last one is still very popular, and a lot of the companies actually reconsider the viewing about manual review. It's plenty of companies who provide manual review, what means that someone sitting and reviewing transaction based on the rules set up for specific companies. But I want to touch a bit about like in-house fraud solution, which is like machine learning and rule-based system. So why we need machine learning for the fraud prevention? So very basic math here. So for example, you're in a middle-sized company, you have, I don't know, 3 million transactions monthly. Like you have pretty standard base transaction level, and you realize that you have a problem with the fraud, and you sign in with someone like a payment provider solution, sign in the contract. As you can see, 80% of the companies right now using outsourced tooling. So that's mean 3 million transaction, and how this company works, they're going to charge you for each attempt of this transaction. They not charge you for success attempts, they're going to charge you for each success attempts. That's roughly, based on the standard fees on the market, about 50,000 USD monthly, or like 600,000 annual. On the top of this, you're also not sure about how these rules and how is it going to work. Plus, you're expecting a lot of the questions from internally in your company, how your rules works, how this machine learning set up on outsourced companies, and you don't have all this information. However, if you're looking on all numbers at the end, most of the companies started from middle size to realize they need machine learning, and they have plenty of benefits to using this one. So first of all, they have a lot of things to control on their side. They know better the clients, they know better all the features, they better know how to calculate precision and recall, because it is a different variety of calculation in precision and recall in fraud industry. However, we have clear picture how we're supposed to be calculate them. Plus, machine learning is great because you can learn, you can set up variety of the features and learn based on the pattern. However, the fraud can change very quickly and adapt a lot of the frauds. Actually, better to say that fraudsters can adapt their mechanism to scam the company much quicker than you're expecting, and you need to relearn ML more quicker than in traditional business like marketing. So I know examples when the relearn happens on daily base, on weekly base, monthly base. Most of the companies try to keep it 3 months. And the plus, what's really crucial for the machine learning is labels, and labels in the front-end industry is a bit something that data science doesn't like, because you can get labels after 180 days after success transaction. That means in 1 day you can getting a lot of the labels of fraud, and after this you need to wait a couple months to realize how effective your machine learning. But if we step down, I'm going to discuss a little bit about my journey with the fraud for these 11 years. So in my first position back in Neobank, this quite popular bank back in Russia, that's going to think of credit systems. What I actually did, I reviewed transaction based on the alert. So it was internal fraud alert system, and what I did, I just like call our customer to confirm verification. My main tool that I used in that moment was Excel. So I export all alerts in Excel file, I fuse them, and after re-upload to fraud solution. It wasn't scalable. It was really bad from the pattern recognition. That means if I see something happens on the platform right now, it took me a while, ages, to find all the customer that's affected on this pattern, because I need to export several Excel files, merge them into the one, make sure my logic is working well. And after this, after all manipulation, it might take several hours, sometimes days. I was able to find some of patterns, but not all of them. After that, I moved to like another company where I start to understand that the data is a bit something more valuable than I expected. That's my fraud knowledge, not as valuable as the knowledge how to aggregate data, how to work with them. And I started to learn how to become analyst. And I started to use my first SQL. It was PostgreSQL. I didn't know anything about SQL, how to use this one, but I was learned in a hard way. That means I learned it by incidents. We have several incidents in the company, and only with the SQL knowledge, I was able to identify the numbers that management asked me. Plus, I learned it in a hard way because, you know, you always have a pressure, and so I asked numbers every minute, and only with the SQL I was able to learn something new for myself, and it helped me to presenting numbers quicker, verify patterns even more quicker, and find information that's necessary to me to find the patterns as well. But SQL was great. However, when I joined the booking.com, and this is my expectation that my knowledge of SQL is supposed to be enough was wrong, because the company in the moment when I joined was 1 million reservation a day. So if I want to run the simple query, it takes me a couple of minutes. If I want to create something more complex, it might take sometimes hours. And when there's something to run hours, and it's usually break down and created a lot of the issues. So for that purpose, I opened for myself Python, and in the booking we use PySpark. That was very helpful for me because PySpark is something close to familiar to the SQL, and I was able to learn a lot of information how to migrate from SQL to Python. And the Python was brilliant for me because I learned so much information, how to aggregate data, how to work with them. And my personal advice, if you look into language to learn, Python is a great one. You can use them for any purposes. And on the top of that, I also had some introduction with RStudio. And the point of RStudio was we created shiny dashboards to create abnormal activities and spotted suspicious activity as well. Compared to Python, R also great. However, I found R more useful if you want to create some visualization. It is much easier than you can do the same things in the Python rather than in R. So Shiny, for example, much easier to set up rather than build Dash on the Python. However, it is my expectations and my experience. I might be wrong, and everyone have different opinions. Something about like fraud prevention approaches, how we're working with the data, how we discover trends. So the first one, it's endpoint centric. We analyze users and their endpoints. We look at the devices, registration information. Is it anything specific we see for these types of customers? Maybe they're using combination of devices and credit cards. Maybe they're using something like IP plus time between customer register on the platform and customer doing the first payment. Sometimes if it's created by fraudsters, it is abnormal activities. For example, normally it takes person to create the first payment on the platform. I know it takes about 3 minutes. However, for fraudsters, it takes 1 minute because they already set up everything on their end to make sure it's, the payments came smoothly without any problems, and they can collect money as soon as possible. The second point is navigation, behavior centric. So as I mentioned already, we're looking on the detection of anomalies. We're looking at the scale of the customers who are registering. Do we see any abnormal activities from specific countries, from specific cards, devices? We combine everything to make sure we're able to identify these trends. It is very crucial for the fraud prevention part. If you're not identify trends or you're not split it out of the whole traffic, what it's mean, you can start to affect on all traffic as well, and you're gonna affect on your legitimate customers, and they will not appreciate it. And the company will not appreciate this one as well, because you're gonna start to create so much trouble for customers who with you on the platform maybe for several years, and they at the end, they might not even back to the platform afterwards if you start to apply a solution on their end. Account centric as a third one, looking on the channel level on suspicious behavior like cohorts, markets. Maybe you see that in particular countries, is it more like more fraudulent activity run rather than another one. The fourth one is cross-channel, looking on is how anomalous behavior correlated different channels. Just looking on the affiliates, for example. So what I mean under affiliates, how the customers come up on the platform. So maybe they are registered via mobile application, maybe they register via web application, maybe they come from different partners. It's very important to looking on this information to make that everything clear and you distinguish out of legitimacy. Sorry, it's best to say it's very important that you really know your pattern and you're not affecting on the whole scale of your customers. Otherwise, you might have a lot of the problems. And the last one, it is entity linking, in-depth analysis based on their all combination of the previous one. So when you have all information on the table, you start to combine it in one piece. Does give you opportunity to understand, okay, so I see the pattern, I see cohorts where it happens, I have plenty of features, how to work with this one, and based on that, you can create rules, or you might start to build the features that you're going to use for machine learning. And another slide, that's why do we need to work with data? So in fraud prevention part, without working with the data, is it going to be the hardest part? As I mentioned in my manual review position, it took me ages to verify and spot a simple scam or trend in ATM machines, for example. But if in that moment I knew, I don't know, SQL, it took me like a couple of minutes to verify trends and make sure I can prevent a lot of the fraud that happens on the customer credit cards. The second one, fraud is very dynamic and changeable path. What does it mean? Today, you might see the activity from iPhone devices from I don't know, from Russia and with Australian credit cards. Tomorrow you might not see this traffic anymore. However, you might see another spikes from another IPs and from another countries. So you only with the data you are able to adapt information. Third one, we need to know who we block, and most important to remember that no fraud. It's not equal growing business. It's actually opposite direction. If it's no fraud, that means it's no businesses, because the fraudsters usually try to targeting the businesses like growing businesses because they have some kind of like opportunity to get more money and where they are aiming here. And why it's important that we know what we are blocked, because it's actually drives us to the next point, labeling historical data. So as you know, the machine learning based on the labels, and without labels, we can't predict, we can't build something useful for the company. And if you are not sure that your data is accurate or that your data is clear, and most important that your labeling existing for the all historical data is going to be very crucial for your machine learning. And sometimes company hire manual review team not for the purpose for preventing fraud, but for reviewing the transaction that's back to machine learning and getting more and more labels. And since we have more and more labels, the precision recall for our model become more accurate. Accuracy will increase, and everyone going to be happy afterwards. So data scientists will have plenty of labels, and they can relearn the model much easier in a faster way. They know what the features they might start to implement if they don't have any historical labels, it's going to be a problem, and it might be not able. They might not even able to create the machine learning in the first place. We should respond for our own data. As I mentioned already, wrong labels from rules, it is misleading information. So if you set up something on your platform to preventing fraud, and you're expecting that you're affecting on only on fraudsters and non-legitimate customers exist there, unfortunately, it's never true because most of the rules, they still affect regular customers. And as I mentioned in the second point, that it's very changeable path. That means your rule might be very sufficient today, but tomorrow it stops affecting on fraudsters and only affect on legitimate customers. However, you start to labeling a lot, and based on these labels, you might start to relearn wrong your ML. The same as manual review. When company decide to work with manual review, they might found the problem sometimes that without proper training, the manual review start to score transaction wrongly, and again, misleading information because the labels is good. And the last one, it actually makes sense. Wrong labels is not equal good machine learning. Maybe it is, but not in my practice. Actually, that's it from my side. I hope I'm able to share something useful for you guys. And I'm going to stop presenting, and I open for any questions if you have any. And I'm going to check in the chat if it's something here.
Ivan, thank you for that session. It was really, really nice. If someone has a question, can they just unmute and then go ahead and ask you right now instead of the chat? Yeah. All right. So Kunle, you can go first.
All right. Yes. So my question is this: you at the start you showed us some figures and about like the total number of cross something transactions, and then how much of it was payment fraud. So why is it that those numbers are increasing? Are they increasing because the number of transactions or the total volume of transactions is increasing, or the payments, the fraudsters are outsmarting the fraud detection measures that are being put in place? Also, you mentioned something about you said, okay, no fraud is not equal to a growing business. So are you saying that if your business is truly growing, you cannot avoid payment fraud? Like, is that what that meant? Thank you.
Yeah, thank you for your questions. Both of them great. Let me answer on the first one. I believe you're asking about like cross-border transaction that's increased for 76%. It happens for a lot of the reasons. The main driver for changing in a way that we see more and more cross-border transaction, that's people realize that it's much cheaper sometimes to order something outside of their country, even if they pay for delivery and the tax at the end. However, great example. I believe all of you know AliExpress. This is a Chinese company that's selling a lot of the stuff. It's kind of familiar to Amazon, but much cheaper. So if I want to buy something like that's, I'm not expecting quality, for example, and I want to buy something that's I'm gonna use, and it doesn't matter if it's broke or not, and I don't want to spend more than £5, for example. For me, it's easier to go and buy on AliExpress and waiting for a couple of weeks rather than pay £10 here in Amazon and getting this one tomorrow. Of course, it depends on everyone, but this is the reason why we see increase of cross-border transaction. Regarding the second question, when I say no fraud, no growing business, what I mean here, that's when the fraudsters try to targeting the companies, they are not caring about small companies because they might not see any benefit there. For example, you set up the company, you start to selling, I know, socks, and you have 100 reservations a day. So you're getting this 100 reservations, you send over, everyone happy. However, for fraudsters, if they want to targeting this shop, they need to find a way how to get benefit. And one way to get benefit, that means they're gonna using stolen credit cards to buy the socks, and after then resell them with a huge price for your customers. But for 100 customers, it's too much effort to do. However, if your business tomorrow start to selling, I don't know, 500,000 socks a day, the fraudsters realize for them to resell these socks and getting real money, it's much easier. It's a reason why I say, if the business growing, it will be in point when the fraudsters start to realize, okay, it is popular. That means we may have some options to getting more money from that business. I hope I answered on both of your questions.
Yeah, you answered the second one, but the first question was actually on why the payment fraud is also increasing. Because I think it went from 17 billion to 48 billion, and then you said it'll probably be even higher this year. So what really is causing it? Is that the payment platforms are not secure, or?
Yeah, great question. I would say it's multiple reasons. One of the reasons that, as I mentioned at the beginning of our session, that right now people have much more payment methods what they pay, and sometimes they're using different sites where they're not sure if it's secure or not. They pay with this one, and actually important to mention that a lot of these transactions, they below, if I'm not mistaken from top of my head, below 5 USD. So what it means, if you, I don't know, spending in a month, let's say 1,000 USD, and some small charges happens on your account, you might not like realize it immediately that this happens. And when you start to see this on monthly basis, something charged from your account, you must start to figure out, okay, I can't recognize that I have any subscriptions. So you're looking on the past and you realize that your card somewhere were compromised, and you start to set up chargebacks. That means you not set up chargebacks for returning money for only transaction for this month. You're asking the bank that your card compromised somewhere time ago, for example, half a year ago, and the bank reviewing and realize that it's plenty more transactions related to these merchants. That was like when this compromised card happens. Plus, you might see a lot of cybersecurity, a lot of the data stolen from the huge banks. So all of them, it's in a complex issue, and it's growing. And it's growing in the same way as a number of online transactions. So if you look on the online transaction going up, fraud going up as well. However, I'm not expecting if tomorrow we see the same number of online transaction, it's going to be more or less the same number of fraud. So the percentage still like about the same value. However, it's a more and more stolen payment credentials in the market and possible found in the black markets.
Yeah, thank you.
I see we have one more questions. Sorry.
Okay. Can go ahead, Lawrence.
Yep.
Hello, thank you very much, Ivan. Thanks. I really understand some of the things you explained. However, my question is around the technical parts. I want to ask, if you look at the processes that you highlighted, I mean, in terms of data processing now, and the rules that you always consider to set up your fraud detection systems. Yeah, you mentioned like you categorize them into 4 different parts. I followed it. I want to ask, the data you use for that kind of analysis, are they all in one? Like, I mean, are the data directly all from the customer, or do you also source from external data to merge because I see that some of the data, probably a user on the platform might not really have all that information. Do you also use some external data? That is one. The second thing I also want to ask is, you mentioned different platforms, especially on how you migrate from using the Excel review to SQL to Python to PySpark and like. So I also want to ask that as you are migrating, at the end of the day, the solution you were able to develop, are they all within the same system, within the same container, like, or do you have integrated system or frameworks that you all put together? I'm not trying to ask about your own personal solution. I just want to have an idea of how you put these things together, how it works in real life. Though I know that the second speaker will also want to do something on Azure, but I just want to understand from your own perspective. And also, last question is, the question from the first person that has the question also mentioned something about.
Sorry, Lawrence. Do you mind if Ivan takes this first too, so that I can then take your last question, so that we don't mix up.
It's okay.
Yeah. Thank you.
Sorry, I was mute. Great. So the first question was about the labeling data, how actually when you work on fraud, what's the source you're getting this data. So I believe most of you familiar with GDPR, and this is sometimes crucial for fraud prevention. So GDPR, it means you are not able to saving customer credentials, which allow you via verification through the database information about customers. And this is actually, when it was introduced in the first place, everyone in the fraud industry started to arguing that it's very important data, that without this data we are not able to build and predict any information. And actually how we traditionally data collecting to starting building some machine learning in the fraud path. So first of all, you have plenty of internal data. It's everything that you can get from a data perspective. If you're able to collect all clicks and time between clicks, if you're able to have any information about countries, about outsourced information. If you're working with outsourced companies, sure, that's the best answer to say, as more information you can get, it's the best options. However, at the end of the day, it might be not necessary that you have all this information in place. What I mean here, that, for example, you have an external provider who collects information about how customers, buy some purchase in different countries. So it looks like useful information. However, for your machine learning and your features, it might be not really relevant, because you are starting to using external providers, and you need to make sure you can trust this data. And I don't know any companies who might say to you that our data is wrong, we never populate right information. So the best approaching, if you building something internally, how it works in the big companies, try to do everything in-house. If you're not able to have everything in-house, try to getting external providers, but make sure that information you're getting from external providers, you can aggregate and you can somehow validate them. Without that, it's no options to set up anything. And I hope I answered on the first questions, and I touched a bit second questions again, but let me know if you still have any questions.
Hello.
Hey, yeah.
Yes, I heard that. Thank you. My last question is that the first person that the question was asked by the first person, and I want to just clarify that the person mentioned something in why the number of fraud is also increasing. And he specifically mentioned that, is it that the fraudster now, are they getting smarter than the system that are being implemented, that are being built, which now link to the fact that in a situation whereby one is in charge of building that kind of a system, what has actually helped you to continue to improve your, the efficiency of your ML system? Like, how do you go about implementing and improving it so that even if, for instance, a fraud actually went through, because in this kind of system, even though a fraud went through that wasn't supposed to be, that would be like a learning pathway. So how do you handle it so that you always keep yourself ahead of the fraudster? But because I feel if that is in place for a specific company, then we can say that they already have a system that is not completely but fraud proof to a little extent. So thank you.
Yeah, thank you for the question. So working with the fraud is have some, I don't want to say positive, however, it's good for machine learning from the label perspective. So when you're working with a fraud, you usually have the strong label that you're getting, and this label calling chargebacks. What the chargebacks means, that's the customer calling to the bank where the customer has a card and asking to return money because customer couldn't recognize this transaction on the platform. And at that moment of time, the bank blocking the credit cards and escalating dispute that's at the end going to the merchant. So this is a true label you can use to learn about ongoing trends, and you're getting information about like chargebacks, and you can see if your model catch it or if it's not, why it's not, which feature do you need to use. However, the machine learning is important part, but as I mentioned in one of the slides, it's best to work with rule-based solution, and to make sure that you a step ahead of the fraudsters, or at least in the same step. You usually have fraud prevention team in a place who looking, for example, under the anomalies that happens in the market. And usually when fraudsters try to getting something, they try to get everything as possible in one moment without waiting extra time. Here is an example from my practice. When I worked in a company that's calling the Get Taxi to aggregate taxi aggregators. In one day, we see that one of our driver start to get, instead of 3 orders, like 10 orders a day. And this only happens for one driver. And a week afterwards, we start to see that this driver is not only one anymore. It is already 5 drivers out of, I know, thousands of drivers who getting more orders than others. Like months after, we see not like 5, it was like 50 or 70 drivers who getting more orders than others. We didn't have much information that moment because we just like figure out based on anomaly spikes that this type of drivers start to getting more orders than usually for these particular regions and this particular market. And after months, we start to getting chargeback for all these orders, and we realize, oh, we missed fraud. We have significant financial impact, and we need to do something in the place to make sure it's not happens again. So what we did in the first place, we set up a simple query that's based on standard deviation and a combination of features, like the grouping based on 3 or 4 parameters to getting the best aggregation information. So you can see that on a daily basis, we start to see spikes, and we start to investigate these spikes and do proactive actions on these spikes. We start to refund transaction, we start to block drivers to make sure it's not happens again. And this is every time happens when you're working with a fraud. To be in the same step or ahead of the fraudsters, you always need to monitoring all aspects of your business. You always need to communicate with all types of departments in your company. You need to speak with marketing to make sure that they open new market tomorrow. You know what's the expectation, how many transactions they're expecting to get. You need to prepare yourself to make sure you have monitoring in place. Plus, you need to make sure the team knows how to spot fraud, how to verify this type of transaction, what we need to put in place to make sure we're able to spot this transaction on early stage, and maybe set up something to prevent this transaction as well. So this is how it works. I hope I'm clear in my answer.
Cool.
Florence, are you still there?
Yeah, I'm still there. I'm still there. Yeah, thank you. I mean, he did justice to the last question. Yeah, thank you.
Okay, that's great.
Thank you,
Thank
Ivan.
you. Yeah, thank you very much, Ivan. We'll have to stop here for the Q&A session. There are some questions in the chat. So if you have any more questions also for Ivan, you can just drop them in the chat. I believe we will try to answer as much as he can. So thank you very much, Ivan. We're moving on to the next session now. Can everyone hear me? Hello?
Yes.
Okay, was I muted before now?
Yes, you were.
Okay, so I was trying to say thank you very much, Ivan, for that session. I don't know if you heard that part. We'll be stopping the Q&A session for now, and there are some questions. There are some questions in the chat. So if you have any more questions for Ivan, you can just drop them in the chat, and I believe we will try to answer as much as he can while the meeting is still on. So please do well to drop your questions in the chats, and we'll move on now. So I mentioned that for the next session, I will be talking about deploying how to train, or build and deploy a payment fraud detection model using Azure's automated machine learning. So it's going to be a simple model, right? Because obviously, if you're trying to build a solution that you're going to add to your business, there'll be maybe more complex data, different features, and so many other things. But then we'll just run through a sample or a demo, you can put it as that, on how you can leverage Azure's automated machine learning. So basically, we'll try to establish the fundamentals that you need to know how to make use of this tool. So Ivan already spoke a little about what machine learning is, but I'll just go over that again. So from what you can see here, machine learning is a subfield of artificial intelligence that focuses on developing algorithms and models that enable computers to learn from and make predictions or decisions based on data. So you have a sample data set, and then you have some labels. I think you already talked about that too. So you want to train a model to be able to recognize those labels on unseen data. So you train with the data that you have for it to be able to recognize data that you're going to input into it, right? So basically, you have a history of fraud and no fraud cases, and you're training your model to be able to recognize future scenarios where fraud, or of course not fraud, can occur. So we'll be using Azure Machine Learning, and it's a cloud-based platform provided by Microsoft that allows users to develop, deploy, and manage machine learning models at scale, right? So you mentioned Python already. You can use Python basically to build your models. You have different machine learning frameworks. You have TensorFlow, you have Scikit-learn, and others like that, right? But Azure Machine Learning gives you an environment for you to actually even use this language to build your own from scratch, or also leverage other tools. So you have automated machine learning, which we're going to be focusing on. You have the designer, which is like a drag and drop interface for you to train your models. And then, of course, you can write your own scripts and train your model from scratch also. So moving on. So yeah, I just mentioned that features of Azure Machine Learning, you have the automated machine learning, Azure Machine Learning Designer, data and compute management. So that's basically you training yourself, and then the compute basically represents virtual machines. So instead of using your the power of your local machine, you can leverage GPUs and CPUs from Azure. So yeah, to start up, we need to create a resource group and create an Azure Machine Learning workspace. We'll come back to this. This is the computer target we'll be using in this session. So compute target, which I already said, is just basically your virtual machine, basically. And all the things you'll be running, all the operations you'll be running are going to be targeted to these compute targets, basically. And they are called jobs, but we'll get to that. Let me know. Just trying to establish some understanding of what Azure Machine Learning helps you do compared to using your regular Python or R to develop your models. So we mentioned that we're going to create a resource group, and in Azure, it's a logical container for grouping and managing related resources in a subscription. So you have your virtual machines, your storage account, databases, and all that in one place. So basically, it's just like you creating a folder where you have your Python script, you have your model saved, maybe you have your data set there already, and all that. That's just what the resource group represents. And then we can see here how the structure works. So you have your Azure portal down to your Azure Resource Manager and the other components under it. So like I mentioned, the computer target is a compute resource that used to train machine learning models, run experiments, and deploy models. So when you create a compute target, you need to specify the type of compute and number of instances. So compute basically is virtual machine, and number of instances is like the number of virtual machines you want to use concurrently. So for scalability reasons, you can set the number of instances to maybe 2 or 3 to make sure that in case of increase in load, there is enough resource to handle such requests or such operations that you might be running. So down to what we'll be focusing on, which is automated machine learning. And Azure Machine Learning includes an automated machine learning capability that automatically tries multiple preprocessing techniques. So instead of you training your models from scratch, right, they are trying this, and I think many of us know hyperparameter tuning and all that. Instead of doing all that manually, trying this model, trying that model, you can actually leverage Azure's automated machine learning to run these different algorithms in parallel, right? Leveraging the power of cloud compute, which are the virtual machines, to run these operations and then find the best performing model for your data. So with AutoML, you can train models even if you lack extensive knowledge in data science or programming. So it doesn't need you to necessarily know, okay, this is XGBoost or this is pandas and all that. I need to manipulate these, or I need to do this feature engineering and all that. It complements that if you have that knowledge already, right? But then if you don't have at all, this is a perfect tool for you to use to build solutions for whatever problems you might have. So yes, I believe we have a full understanding of the basics of how Azure's automated machine learning works. So we'll get started into the workshop session now. So you can head over to this repo. I'll copy the link and share to us in the chat. Let me just copy that. So if you're following, you can just head over there and continue with us. So yes, coming here now, you have the procedures for you to run these projects. Yeah, that's what we call it, for you to run this project on your local machine, right? So you can then do some other experimentation you want to do and go ahead to deploy it or whatever you want to do for your for the solution you are trying to provide. So I've completed the code here. I've done most of what we need to do. So what we just need to get is our key, API key, and endpoints that we'll get from Azure after training our model and deploying it. So if you want to follow as we are going on, you can just follow these instructions here. Clone the repository to your local machine with this. You can decide to rename it, but make sure you change it here also. Create a virtual environment, activate it, install the dependencies which are here. So like I talked about pandas and other things that you might make use of. Everything has been compiled here, so you don't need to worry so much about that. Of course, you can take your time to do some research later on, but then you can just follow this simply as we do that. As we continue with this session now. So there's a demo video here. I already put that on, so you know how the solution works. So let's get us started. The first thing, like I already mentioned, is to create a resource, right? A resource group. So normally, if you want to create an Azure machine learning workspace, right, there's an option for you to just create it directly when you search, but that hasn't been working since like yesterday, probably a bug that will be fixed. So what we're going to do is first create our resource group separately, right? Create our resource group separately, and then we'll now go ahead to create our Azure Machine Learning workspace. So let's name this payments fraud. Yeah, okay, payment fraud detection. Right now, it's recommended you use a location closest to you. So I use West Europe. I mean, if you are joining Nigeria, I think that's the one of the best regions you can make use of. So West Europe, and then click review, create, and then create. So this is run. The resource group is created, and then we can go to our resource. We don't actually even need to go to the resource here because we still need to create our Azure Machine Learning workspace. So we can click to create a resource again, search Azure Machine Learning, click that and then create. So like I mentioned, normally you would have been able to create here, but since we already created our resource group separately, we don't need to like go over that again. So we can just name this payment word workspace. Let's put it as that, and change this to the same location as our resource group, and then the rest are auto populated, so we can just go ahead and review and then click create. So but I should have mentioned this before we started. If you're a student and you're on this call, Azure is not completely free, right? So for students, you can get $100 credits once you verify that you're a student to do whatever experimentation you want to do. As a Microsoft Learn Student Ambassador, you get $150 monthly, right? But then as a student, you can just sign up generally, you don't need to input your credit card, experiment with all the services that are available, get your $100 Azure credits free, no extra charges. Your credit card is not connected, so you don't need to worry about maybe unnecessary extra expenses that you might incur if while doing whatever experimentation. So while we're waiting for this to deploy, let's just quickly explore our data. So like I mentioned, it doesn't necessarily need you to have full knowledge of how machine learning or Python works, but I've done some pre-processing as a machine learning engineer myself, and I just want to run us through the code. So yeah, let me just scroll up to this. But before we do that, let me activate my virtual environment here. So activate, and then also for this site. Okay. So I imported pandas, and the sample data set was gotten from Kahoot. You can just check that from here. I already referenced the link here. So you can head over to this link and you can check out the data sets on Kahoot, right? See all the features and everything, and decide to download yourself and do whatever experimentation you want to do. So we'll come back to our code. So let's head over to the Azure Machine Learning Studio and begin to work, basically. So this is loading up, and then we'll just click Launch Studio. So it opens up a new interface for you where you do all the experimentations you need to do. So from training your models, whatever you want to make use of, maybe the designer tool or Azure Automated Machine Learning, and every other thing you want to do, you can find them here. So the first thing we want to do is we can decide to create a data set first, like add that. So we have computes under the manage section here, and you can see automated machine learning under authoring. So let's create our compute cluster, which I already mentioned we'll be working with. And then, okay, West Europe is already selected. We're gonna use DS11 version 2, V2 basically. All right. And you can see this cost associated with making use of this virtual machine per hour. So one thing you need to know is that once you're done training or whatever operations you're running, it's recommended for you to stop or delete whatever compute you might have created so you don't incur losses on what you are not making use of. So we click next. So well, before we do that, you can actually check some other GPUs that you can leverage. So for example, you're doing a lot of heavy work and probably you're deploying to a heavy you're expecting huge traffic, or the kind of data set you're working with is pretty large, then you can make use of those GPUs. But we are not doing something so heavy, so we'll just make use of this CPU standard DS11 B2. So we can name this payments fraud cluster. Yeah, and let's change the number of nodes to 2. I already explained what the nodes represent. You can see that from here. So maximum number of nodes that you want to provision. So the computer was to scale to a maximum of this node. So once it's notices that one node cannot handle that, right, it scales up to 2 nodes. So that's the beauty about compute cluster, right? It's a scalable compute that you can use for training and what have you. So we can go ahead now to create this. And then once it's done, we'll add data. Okay, successful. And then we can go ahead now to add the data for this. So just click create, and let's name these payments for data. Right. Okay. Payment for data, and we're working with the tabular data, so you can just click next. So you have so many options for you to create or source your data from. You can get them directly from your file, or you can get them from a web file, like the link now. Let's say you have data sets stored on your GitHub repo, you can just get that. SQL databases from Azure Storage, and also Azure Open Data as data sets. So like data sets that already exist in Azure, you can just make use of them. But I'll be using the data set I already pushed to the GitHub repo to select from web files, right, under experimentation and under data. So I'm going to select this one. Like I mentioned, I already did some work on it. So like some feature engineering on it. Just created one more feature actually, which is percent out here, which calculates the amount of that transaction divided by the previous balance before the transaction of the originator. So I'll come back to this, but can select this here, click view raw, and I just wanted to get this linked out for me, and we can go back and input this. So yeah, we'll go ahead and just change this. Since it's only one file, the data set has only one file, and so let's go ahead to do this. Can check whatever encoding it is, and then continue. So you can see the data here already imported. And click next. So now this data set contains the flagged fraud, right? So probably you already worked on your on a model before, or probably manually or something, and then you're trying to compare to the ones that were actually fraudulent and the one that you marked fraud. So this data just basically contains everything. So, but we don't need it, so we're just going to remove that from the features, and we're also going to remove the name. We don't necessarily need the name of the originator and also the name of the account of the recipients. So with this, so I go to go. So step represents the window that the transaction happened. So in hours, and in this data set, the maximum was 10 and the minimum was 1. So like between 1 to 10 hours, how long or what was the window that the transaction happened. So we click next and create. Does anyone have any questions so far? Am I audible? And is there anything that you might have missed out while we're going on? Everyone is good?
Okay, I have a question.
Okay.
So at the beginning, it was mentioned that if you have, like, you don't have, what was the word? Basically, you don't have much knowledge of machine learning or programming that you'll be able to do this, but you showed us code. So if you can't write code at all,
if you can't write code at
we
all,
used to be able
you are
to do
good to
this.
go.
Yes.
Yes, definitely.
Okay.
Definitely. So we're heading to that. So basically, what we've done so far now is just for me to create data sets, create the compute without any code. I was also showing you that, okay, I did some pre-processing as a knowledgeable machine learning engineer or data scientist, because I know, okay, it can actually improve this or improve that, right? That's why I showed you that. So I'm saying that Azure or automated machine learning does not eliminate the importance of data scientists or machine learning engineers. It complements your work basically. But if you don't have any knowledge at all, it still does a good job, right? So that's my point. So you can explore the data set here, see the distribution of the data, which you can do with maybe Python, do some visualizations. So you can see the total number of transaction times we have here, the distribution of the step, and other details you can go ahead to check. But let's move on to automated machine learning now, which is under authoring, right? So click new automated machine learning job, and what job basically represents is the operation. So whatever operation you run in Azure machine learning, they're called jobs, and then you can keep track of them under assets here, the second option of all the jobs that you have run. So we're going to select this data set which was created just now. Next, let's name it payments fraud train, right? Our target is fraud. We're trying to predict whether it's fraudulent or not. So that's either 0 or 1, right? So it's already auto selected the compute cluster we want to make use of. So we can just go ahead to click next. And then we can select it to enable deep learning. So what we're doing is a classification problem. So we don't need to change anything. You can just enable deep learning. So like for this might not be necessary for the kind of data set we're working, which is not so large, right? But if you're working with something much larger, definitely based on your on the solution you're trying to work with or the luxury of data set you have access to, right? You can enable deep learning to create better models, because the larger the data, deep learning models outperform your generic machine learning algorithms like your logistic regression and the rest. So we can view additional configuration settings, right, by using AUC weighted. So AUC basically means area under curve, right? It plots some metrics for you, right? So you have your true positive rate plotted against your false positive rate. So what the weighted now there represents is that in comparison to other metrics, so let's say, for example, for classification now, I believe we're familiar with accuracy, is very popular. Accuracy just basically means the total correct predictions divided by the total predictions, like the total point. And weighted here now represents that if you are basically trying to compare between the AUC now and accuracy, or let me even let's say use the R squared score, right, which helps you check the explains the variation of the data set from your predictions. If you're just randomly guessing, they are on different values, or you might say they are similar. Most of them are between 0 and 1, right? But then they don't necessarily represent the same thing. So weighted means that it's normalized basically. So if you want to compare AUC and for example with R squared score, so you most likely want to do a comparison AUC weighted and R squared weighted. So we kind of put them under the same scale, and then you can say, okay, this one is higher, this one is lower, then compare basically. Just putting the same putting different metrics under the same scale. That's basically what it means. So you can decide to check other models. Let's say you don't want to use all. You can select. So you can see a list of algorithms that you can leverage here, but we are just going to select it to use all. And prediction class, or the positive class, is the positive class label, which is 1. So 1 represents fraud. And then we can now set the maximum amount of time that we want to train. So I'm going to set this to 0.5, which represents 30 minutes, but it's going to finish before that because of this now. So the metrics score threshold basically represents that once you get this particular score, which is the AUC weighted score, it terminates the job or the operation, right? And then you can just view the best model. So you have this option here that explains the best model. You can also even generate the code of the best model if you wish to. So I'm going to set this to 0.9. Let's be ambitious. Let's say 0.95. And concurrency, we'll leave it as 2. So the minimum actually you can set this to is 0.5. So that's why I'm setting it as that. So we can click save, view featureization settings. We don't need to change much here. We're good to go. We're using all the features here. Save. This fraud is the target. So next. So yeah, for those that have knowledge of machine learning and data science, what this represents is that you're trying to, while training your model, it wants to carry some validation or testing to see, okay, how does it improve the scores, or what can it compare it with? So, and since we don't have a separate test data set with labeled values, definitely. So I just want to split our training data set into 60% for training, and then 20% for validation, and then also 20% for testing, which we will see like for the metrics that it will show us. So we can go ahead to finish this now. So it creates the it tries to run the model, creating the job, and then we can now, we'll just have to wait a few minutes for it to run. So while that is on, let me go back to the code to explain some of the things I've done and what I was trying to explain, right? So we can just go ahead and refresh. So it says running now, setting up and all. So like I was saying, we've loaded the data set here using pandas read CSV function. And then you don't need to bother yourself about this basically. But so now the feature engineering that I did, which I don't want to explain, is that I created a new feature in the data set that considers amount and then the original balance of the originator before the transaction happened, and then it calculates the percentage. But then if you check through, there are some values that will have been marked as infinity. So before we get to that, the total number of types of transactions we have in the data set is 5. So we have payment, transfer, cash out, debit, and cash in, right? So these are like important features for the data set. So coming back to this, I just try to check this to see, okay, what kind of transactions or how many of these transactions had a greater amount than the original balance from the originator. So I found out that some of them were saved as infinity. So basically a division by 0 occurred, right? So probably the like we can see from here now, the balance of the originator before the transaction was 0. So passing this into Azure's automated machine learning. Of course, we didn't have this issue until I did my feature engineering. So you still don't need to bother about the code, right? But then passing this into Azure machine learning or Auto ML to create the data set, it regards this as a string, but then we're actually looking at decimals here. So I changed those values to 0. So wherever you have an occurrence of infinity, change those values to 0. And that's what I just did here in this code. And then I saved the data set. So I also selected 50 points, so like the first 50 points in the data set that we use to test our deployment, basically. So that's just a summary of what I've done in this notebook. Nothing too complex, and then you can, in your spare time, also go through it when you wish to, or like after this event, or if you are following us right now in code. So just waiting a few more for this to load, and then we'll be able to view the models. So yes, like I mentioned, right, by the time we train and deploy our model, we're going to get an API key and a URL that will be sent, right? That will be queried basically for the predictions. So I also wrote a script already that does all that for you. Okay, let me just open up this, right? This is what Azure is going to give you. So basically, you still don't need to do any code. Azure is going to give you this code itself on how you can query the data sets. So we have this is stored in JSON, right? In Python, it's called dictionaries, but then in actual sense, it's JSON, right, as you can see here. So the data set is collected as in JSON and then sent to the endpoint to generate your prediction. So these are the features. This is marked as string because the types are payments, caching, which are strings, and then percent in and out, which is the feature engineer, the engineered feature basically. So I use Streamlit, right? Like I said again, you don't need to worry about yourself at the code. If you have your solution or in the place where you work, right, you most likely have a dev team that will handle all these code on deploying your model or how to make use of them. So, but as a data scientist or whatever role you occupy, you have built the model, you've tested, and then all you need to give them that Azure will generate automatically for you is the sample code, which I've posted, shown you here, that we use to generate predictions, and then the API key and endpoints that they need to use. So just imagine I'm part of the development team, or if you're a machine learning engineer, also a data scientist, is also a good addition for you your skill set on how to deploy models, and Streamlit is a very good tool for you to use for that. So you have the sample input here where you can type in the values, and then you click run, and then it makes your prediction. So I've created the function to predict data, encapsulating everything Azure generates into here. So once I run this, it generates predictions and it returns whether it's 0 or 1 for me. And I also created another function called batch predict, right? That's so in case you don't just want to enter one data at a time, you want to select a file that contains the exact same features basically, and run predictions on that. So you can just use the batch prediction section to run your model, and then it calls this here and makes your predictions and puts them in the folder, names it as is flagged fraud because it's not fraud yet, it's just a detection. So the folder, the column is titled is flag fraud, and then you can just use that as well, make your decisions. So while I'm still waiting for this to finish up, does anyone have any question at all? Maybe as regards making use of Azure machine learning, or any question at all, how you can leverage it and all. Hello? Okay, I guess we don't have any questions so far. So we'll just hold on a little. So performing featurization on the data, which is basically what I just talked about, creating a new feature. But then Azure helps you create so many other things. You can keep track of what is happening here. So like I mentioned, the jobs are the operations, and you can check out child jobs there. So for example, it already mentioned it's performing featurization. So many of these things are like components of the actual building of the model. So you can check out what is running here under child jobs. You don't necessarily need to go into it, but then just to like a confirmation that something is happening, and then just to have that at the back of your mind. So on average, like I mentioned, it just depends on the volume of the data set you're working with. So if you're working with something maybe much larger, you should know that you should select maybe larger compute targets for it to run faster. And then basically everything depends on the compute target and the data set you're working on in terms of speed, and then in terms of the accuracy you want to get out of it. Okay, so we can see that model training has begun here. All right, so there's no model appearing yet now, but model training has begun. So that will take maybe a couple of minutes, and then it will terminate once it gets the model with the best score for us. Okay, so discussing the transaction types now. I mentioned that there were 5. We have payments, which is transfer of money from one party to another, cashing, deposit of money into a bank account, cash out, withdrawal of money from a bank, transfer, which is similar to movement of money from one bank account to another, and debit, a deduction, basically. So now, this is just a sample data set, like I mentioned, for a real world scenario. You might have so many features that tracks maybe the kind of transaction that is happening, which we can say on that type, but then maybe recording the duration, tracking the window, like how many things changed within that window. So let's say the transaction happened within an hour, what other things went on within that same range, and so many other things like that, right? So many other things. So it's just a sample data set. Like I mentioned, we're trying to build a simple model. So you can go ahead to like experiment with maybe other sample data sets you might have access to, or whatever solution you're trying to work on. So our model training is done, and then we can see that our best model is the Max App Scaler from using XGBoost. So Max App Scaler is like a factorization tool. So you have standard scaler, you have Max App Scaler for those that try to build models with Python, right? And I think many of us might be familiar with XGBoost and LightGBM. So we can go ahead to check. So we can see that now the weighted score is 0.84254 base for. It's just going to explain the best model for us. So we can go ahead to click on this, right? But before we go ahead to deploy, let's check out the metrics. Let's check out the metrics that is generated for us. So you can just scroll down here and see the confusion matrix. So this is, to be honest, like a perfect model, because when you're trying to build something that detects anomalies, for example, a fraud detection model, you're trying to maximize the model to be able to detect the lower case, like the one that actually causes a problem. So I didn't mention that at the start, but then this data basically is an imbalanced data set. If we can see from here, right, from this notebook. So I try to check the distribution of fraud cases compared to non-fraud, and you can see that over 100,000 were not fraud and just 116 were fraud. So if you want to compare, you can say that the fraud cases were just let me just do this quick. All right. Fraud cases was just, in fact, let's say less than about 0.1% of the whole data set, 0.1%, which is pretty low. So if you use something like accuracy as your major metric now to compare, accuracy, if it predicts everything as not fraud, you're going to get over 99% because it tells you 0.1% is just the fraud case in the data set. So you can get as high as 99.9% if you just stick with accuracy. But if you use accuracy, the actual fraud cases that happens will not be detected. But then you might assume that your model does well. So that's why we're making use of AUC. And if you are familiar with other metrics like recall, precision, and then F1 score. Yeah, I think I mentioned R squared score. That's for regression. I meant to say F1 score basically, right? F1 score compares your precision and recall. So just to correct that. So F1 score is another metric that you can use. So we can see here, and then we can go ahead to model explanation. So you can check out other metrics, right? You see the recall score and other things, but before that, you can see the feature importance. So you can even you can see here from this feature importance that is displayed that the percent in out feature that I engineer myself is the second most important feature while training. So that's my point, that if you have knowledge of data science, automated machine learning does not just eliminate your skill, right? It actually builds on it, or helps you to polish it, in the sense that all the heavy hyperparameter tuning and stuff that you might need to do for maybe a quick solution or something, you don't necessarily need to perform that. So the type of transaction contributed the most, then the balance of the recipients before the transaction, and the balance, and the balance of the recipient after transaction was the fourth most important. So we can go ahead to click model importance and check the scores here. You can see that the accuracy is approximately 1, recall 1, F1 score 0.923, which is pretty high. So now we can go ahead to now deploy our model, right? And just come over here and click deploy. So we'll click web service, right? Because that's what we're trying to experiment. So let me call this payments fraud model. And okay, I need to use lowercase. So we're going to deploy using an Azure container instance. We are doing basically not much heavy work in terms of production and stuff. So this is a go-to compute type you can use for your deployment. So, but if you are doing some much heavy stuff where you want to be able to monitor in detail your model and its performance, you can go ahead to use the AKS system, which is Azure Kubernetes Service. Right, so we're going to enable authentication, which gets you your API key and endpoints, so that not just anyone can make use of it using the endpoints URL. So you have a key that will be generated to help restrict access. So we can go ahead now and deploy. So then there's something I want to point out, right? Is that we've talked so much about data, and then I don't know how much or how much awareness we have on data collection, right? If you have a business or if you're part of an organization that does not have proper data collection systems in place, then you cannot actually really leverage data. So you can say maybe your manual checking or comparison with paper. Okay, you have this document from this customer and all that. You check, okay, you check their transaction details and all that. You don't suspect anything. That's not scalable. It might be effective, but it's not scalable in any way. So to properly leverage data for fraud mitigation or prevention, there has to be a proper system in place for collection, right? Data collection. So this will take about, I would estimate, maybe 10 to 15 minutes. So while that is on, let's have a game session, right? I think many of us are familiar with Kahoot. So yeah, we're just gonna do this quick and then get back to our workshop. Okay, so everyone can join in. The code will be generated, and I'll recommend that whatever nickname you're using to join in, right, I would like you to, before we start now, right, before I begin the game, I would like you to drop in the comment section maybe your name or your email address, right? Your name or your email address to accompany that nickname that you're going to use to sign up, so that I can keep track and reach out to you for your prizes if you win any prizes. So so yeah, the pin is 433-3766. If you are joining on your phone, I'll recommend that you change your browser settings to desktop mode so that you can view the questions. Right? If you are not using your phone, you won't be able to see the questions. You will not be able to select options. But join in and change it to desktop mode. If you are using your laptop, you see the question straightforward, so you are good to go. So the game pin is 433-3766. I'm waiting for us to join in. Okay. Are we together? Okay. One person is in. All right. Everyone can join. Like I mentioned, there'll be practice. So it's what a try.
On my way.
The game pin again is 433-3766. Let me drop that the chats. 433-3766. 433-3766. So you can use that to join in. We're still waiting. Any issues joining in, just head over to kahoot.it www.kahoot.it, and then you'll be asked to input the pin. Let me type the URL here. Okay. Yeah, I've sent that in. So, okay. I'm just going to wait a few minutes for others to join. Please don't forget to add your nicknames and your email address. So your email address will be most preferable so I can reach out to you for your prizes. So okay, wait a few more seconds for maybe 4 or 5 more people to join in, and we'll get started. Okay, we'll have 9 people here. I'll just wait 1 more minute and then we'll get started. The game pin again is 4333766. 4333766. Are we good to go? So I'll leave this open. So in case you still have issues joining in, you can just join in as we begin. Everyone is welcome to play, absolutely everyone. So let's get started. Okay, so we have our first question here. Leveraging data to prevent fraud helps apply a scalable solution. How true is that? Or how false? Okay, wow, that's nice. 9 people got that. Of all the 9 that answered, got that right. Cool. Let's see who is up top. Koniho. Nice, nice. So let's go over to the next question. Under what section is in Azure Machine Learning Studio is Automated ML under? Is he under authoring, assets, or manage, or is not even in any of the options? Ooh, only one person got that right. Wow. Okay. Let's see the streak. Toki. Nice. Nice, nice. So Toki on the race. Let's say the third question. Which of these is not a transaction type in the data set? So there were 5, and one of these is not among them. So let's see how many of us can get that right. Oh, just one person again. Wow. Okay, I guess. The pin is 4333766. In case you still want to join in, the still open, and you can participate. So okay, Toki still maintains his streak. I mean his rank basically. So 4th question now. What is the relationship between fraud and business growth? I'm pretty sure if you followed Ivan explained this again, and one of us also asked a question on this and he explained again. So this should be pretty easy, I guess. Okay. How many of us got that right? Sorry, I just lost connection a bit. Wow. Oh. Oh, my bad. Well, I guess maybe the first questions have to go again. Let's just quickly join in. I sincerely apologize for that. My network did me dirty there. So the new pin is 6849340. 6849340. Yeah, I mentioned that since we have some completes here, Kafaya says you can read the question. Now I said change to desktop mode. Change to desktop mode. You'll be able to see the questions if you are joining on your phone. Change to desktop mode. My sincere apologies for that. I'll just wait one more minute for us to join in. The pin again is 6849340. 6849340. Let's see if we can get to 9, then we'll go ahead. I'm really, really sorry for that. Six eight four 9340. 6849340. I hope everyone can see the questions when we get started. So I'll continue now. You can still join in. So seems like the first 4 questions will be like a bonus for those of us that might have seen that. Well, let's see. Okay. All right. I think the first time everyone got this. Oh, one person didn't get it right. Okay. Let's result of okay. Toki is back. So under what section in Azure Machine? Under what section? Let me see if people paid attention to this question. A lot of us got it wrong. Let's see how many we get it right this time. Ah, seems like everyone took notice of the errors. Okay. Toki again. No one was ready to challenge Toki. Which of these is not a transaction type in the data set? So the pin again is 6849340. You can still join in and participate. Okay, almost everyone got that right. Kunle is on a streak. Nice. So next question. I don't think we got the answer to this. Okay. So let's see how many of us will get this right actually. This is where I lost connection. Oh, okay. Majority of us got that. So like I was trying to say, Ivan emphasized that a lot. And so it's good that we are following. Okay, Toki is coming back up. Kunle hosts it up top. So yeah, for our 5th question now, automated machine learning allows you to train models without extensive data science or programming knowledge. True or false? So for you to see the questions, like I said, you can change your phone to desktop mode so you can see the questions. So I have the answer there. True, because you don't need to have so much experience to make use of automated machine learning. So basically helps you to work with little experience. So now we have this. In Azure Machine Learning, operations that you run are called what? Compute, jobs, workspace, or resource. I also talked about this like some minutes ago. Nice. I guess most of us were following, so that's good. Conley up top again. Who's going to challenge him? Who's going to challenge him? Which of these is not a language used in analyzing data? Which of these? Okay. Okay, majority of us got that right. Excel is actually not a language. It's not a programming language. It's a tool that you can use for analyzing data, but it's not a language. Okay. Toki is trying to come back up. Streak of 7 by I know 1 to 3. What a nice nickname. In what format does the endpoint accept requests for prediction? So I mentioned that. Yeah. I was trying to make a comparison in Python about what you can use. I'm not saying it's Python though, but then what formats basically do you send requests? Wow, almost everyone got that right. JSON. Nice, nice, nice. Ooh, I know 1 to 3 has taken over. Conliho, it's probably his streak has displaced you, I guess. So for our 9th question, Azure Automated Machine Learning completely eliminates the need to perform feature engineering and other data preparation techniques. Does it? Maybe yes, maybe no. Let's find out. Nice, nice. So yes, like I mentioned, it doesn't completely eliminate it. It does actually makes you better if you have those experience or those skills already. So wow, I know 1 to 3 has lost its place. Extraterrestrial. Streak of 9. Let's see if you get the 10th question right. So final question for decider. You cannot leverage data for proper decision making without a proper data collection system in place. Probably true or false? Let's see. Okay, that's true. That's true. So let's see who takes it. Third position we have Conliho. Nice. I know 1 to 3. Let's see if Extraordinary got this. Extraterrestrial. Oh, he did. Nice. So we have our top 3. Thanks for all those that participated. So Toki and Noel runners up. Thanks for participating. I'll reach out to those that are winners and you get some feedback from me. So let's go back to our code. So the model should be done. Okay, deployment successful. So now we're coming towards the end. So we've done our deployment and then just gonna say it's healthy. So you can come over here to test. So it gives you a testing environment for you to try out the features, right? So if anyone is okay, let me just try out some samples, right? Let's say we have 2 here, and we have a payment, and the amount the transaction was, let's say 2,000, right? And the original balance was, let's say 6,000. The new balance, let's assume it was debited 1,500. And you can leave these as, let's say 200 or 0, and leave the percentage out. If we do 200 divided by 60, we're having 0.33333. So let me just, 2,000 divided by 6,000, that'll be it. So let's leave it as that. And then we can click tests now. So it has classified it as not fraud. I don't know if this is clear. Let me change it to light mode so you can see my screen, right? So 0 basically represents no fraud, right? And then with that, now we can move on to the code. Like I was trying to explain, Azure generates this for you automatically, so you don't need to really stress, okay, what I need to know to query the data. This is the URL, and then you can just copy out one of the API keys, right? You can use the primary or the secondary. So let's just copy this out. I've already created a file that will contain my keys, and I didn't put that to GitHub because that's standard procedure. Your keys shouldn't be exposed, even though I'm still going to delete this after we're done. For, of course, security reasons, it's very important you do that. And you should also avoid exposing your keys, because if it's leveraged, if it's used, then it's going to incur some costs on your end. Meanwhile, you're not the one making use of it. So we're just going to copy this REST endpoint, right? It also generates code for you in C# and R, whatever tool you're using for your deployment. So we copy this REST endpoint and move to our code here. I created this environment, this file here, and copy the key here, and then copy the primary key, the endpoint there and the key here, and go ahead and save, right? You can go ahead and save. So that's that about that, basically. And then, like I mentioned, you don't need to bother yourself about the code. From the visualization, you understand what is going on. So these are the 2 main things that we need here. So I can just go ahead to close this. If you're following, you'd have gotten something like that, and then you use just copy and paste into this. Though this will not be generated, but you can just create this and then import at the top here .env. Let me scroll down to the part that has it. Where is it? Okay, yeah. So .env, load.env, that what I use. You can also use environment variables to do that. So I just created the file and loaded that file in, and then we're good to go. So I'm going to run a code on my terminal now that's going to call up the web interface. So it's just basically Streamlit. You can see it also from here in the repo. I already added that. So you just click this. So let me just even copy it from here, right? And then we click, okay, added an extra S. And then we'll click this, and it brings up a local interface for us to do our testing and our running. So I'm just going to copy this URL, right? I don't need to use Safari, so I'll just code this and go back to my page and paste this in. So I already set up a logo that we can make use of, like the page icon, which is the credit card emoji you can see here. And then, yes, so this is what the web interface looks like. So let's go ahead and test one of the data points actually, right? We have here, okay. So let's use one of the data points from the data sets. Scroll up to this point, step with one, payments, and then amount. So let me copy this amount, go over here, select step is 1, payments, the amount of the transaction, and then you click enter. And then the initial balance is this, right? Enter. The old balance is what? This. And for the recipient is remains 0, so we can leave that. So let's copy this and so you don't need to actually type in the percent in and out. I already did that in the background in the code. So if you check somewhere, you see that that will be calculated for you around here. So we don't obviously not calculating, okay, amount divided by balance before transaction. We don't need to do that. So once we run this now, it says no fraud detected, right? So we're going to go and it shows you displays this image. I mean, this is pretty cool. And then we can go ahead to test with the fraud case. So let's test with the third data point actually in the data set, right? This one that was actually flagged as fraud. I mean, that's actually fraud. Yeah. If our model would detect it as fraud also. So the type is transfer. The step is 1. The amount is 181, same as the old balance, and the rest is 0. So we're going to change this to transfer. Amount is this. Initial balance is also this, and this is 0. So let's run. So you can see our model actually detects it rightly, right? And says fraud detected and displays this image, which is pretty cool. So we can now go ahead, like I was trying to explain batch prediction, where you have a file that contains the same features or so many other features, but it's just to take out the feature that was used to train, right, and make the prediction. So let's run a sample. If you try to select, because you can see it clearly displays choose a CSV file. So I defined a tests for errors. So you try to upload a file that is not a CSV file. So let's say you try to upload this PDF, right? It shows you not a CSV file, right? And if you try to upload a CSV file actually, but does not contain the right features, it tells you, and you click, it displays that you can run now because it's detected as a CSV file. But when you click run, it shows you that the file contains the wrong data. So these are things that I've already put in place, which are some of the things that maybe the software engineers and the place you work or solution you're trying to build would work on. If you don't have the skill already, not necessarily you have to, because that's not like really your domain. So we're going to select this, the test sample I've created here, which contains just 50 data points. You can see how small it is. And then we'll click run. So you can actually come back to check your model here, check deployment logs, right? Let me change this back to dark mode quick. You can check your deployment logs to see what is going on, the requests that are being made and all that. So it's a kind of form of you monitoring what is happening with your endpoints, with your detection model. So now it brings out an option for us to download the predictions, right? So it has been compiled successfully. And then I can say I want to open this up. So let's open the file. Let me see if that is okay. I'm opening that up already for us. So yeah, we can see here now, like I mentioned, that the feature, the column that is created is we named this flag fraud. So we can actually take this and compare with our data set and see if it actually does a good job, right? So we go to this, we can see that the ones that were actually fraud, 00111, I mean 00110 for the first 5 sequence, it actually matches that here, right? You can see. If you want to go on to check more, we can. So let me just quickly load this up, right? And add that, and then we can say fraud.head 10. So displays the first 10 for us. So you can see even after the ones that were fraudulent, right? The rest were 0, and same applies here too. So for the first 10 up to this point, right, everything after the fraudulent is marked 0. So we can say our model does a good job in prediction. So this wraps it up actually. But before we go, I just wanted to re-emphasize on maybe it's not totally necessary, but if we try to create a new model, right? If we try to create a new model with this data set, but then removing that percent fraud, we'll see that the accuracy we're going to get is going to be much lower. We're going to stick with this. Let's see if we can get that ready before we sign out. So I'll just show us that. So still enable deep learning, change the exit criterion to 0.5. So let's say this is 0.9 or 0.85, right? Since you're just testing it out with your data set, or you're not done any feature or engineering or anything, you're just testing out. So you're not so ambitious yet, so you use 0.85, and then we save it as this, right? And we click save, and then we change the features. We remove the percent out feature, since we're assuming that we've not done anything, right? You're still going to get a pretty good result, yes, but when you have the skills, it even makes it better. So let's change this to 20, and then 20 also, and finish up. So we'll just wait. If it doesn't finish before we end, that's fine. But I just wanted to use it to compare you having a knowledge of data science or machine learning already, how it adds to it. So this is it actually. This wraps it up. We have our model working very well here, running predictions, detecting these as fraudulent, and then this is how you can make use of Azure's automated machine learning to create an online payment fraud detection model or solution. So thank you for sticking with us up to this point. If you have any questions, just kindly share them now, if you do have any. Do we have any questions? No questions?
So just to clarify,
All right.
the CSV file has to be in a certain like how not okay not I don't mean format as in .csv, like the way the data is entered into the CSV file. It has to follow a certain pattern for it to work with the specific model.
For your prediction, right? Yeah. So whatever you've
Yes.
trained with. So let's say you trained your model to have using 5 features, right? So let's assume we trained. Let me head over back to the code. We're trained with step, type, amount, and then let's say the old balance of the originator and the new balance of the originator. So basically before and after the transaction. Whatever you're using to predict has to remain that way. So you cannot now bring in old balance of the recipients when you didn't train the model with that, right? So that was basically how machine learning works. Whatever data you've used in training has to remain the same way. Whatever model you use in training has to remain the same way. You get. So you cannot bring in a new feature for prediction, except now you can retrain your model with that extra feature. Probably you didn't have it at the time you trained your model, or now you have it, so you retrain your model with that new feature. I don't know if that answers your question.
Yes, thank you.
All right, thank you. Kafayat, you can go ahead.
Good evening.
Good evening.
Sam. Yeah.
Yeah.
The question I just want to ask is, what you said earlier, that for students, before a student can enroll, can make use of Azure, that is sign up for Azure, he has to pay $100.
No, I didn't say pay.
Okay?
Yeah, I said you have access to it for free. So if you are a student, you are eligible to $100 Azure credit for free. You just have to verify that you are a student, and you get that. So it runs for once you finish it or something. So, and you don't need your credit card, anything to plug into. You just sign up. As long as you verify that you are a student with probably your student account or maybe an ID card or something, you get $100 Azure credit for free, and you can do exactly what I've just done with with Azure.
Okay, thank you.
Yeah, thank you for your question. Any other questions? Okay, Kachi.
Okay, good evening.
Good evening.
Samuel.
Yes.
Thank you for the session.
Thank you.
Okay, so I want to ask Azure Auto ML, right? You said for students that you just need to verify that you're a student and then they will grant you some $100 card or something.
Yes.
So I want to ask for people who are not students, right, who are new to it, they just want to test, they want to see how it works, they want to learn it. Is there any way you can go about it?
Yes, actually, there's a pay-as-you-go resource that you can make use of, and obviously it won't cost you so much. Let's say about like all that we've done now. If you actually check through it, I don't think we've used up to maybe $1 or $2 or something. So you can use that to experiment. And there are some other things that you can make use of. I don't have definite specifics to give that to you right now, but I know that there are some other things that you can make use of if you're not a student that gives you like access to use some resources without paying. I don't know. I think if there's any student ambassador that has information on that, you can just share that. I don't have the exact details, so I don't give wrong information. But then I know there is actually is a platform, or how do I put it now, something, basically a plan, let me put it that way, that you can make use of to do some experiments for some time, right, based on services they're using for free, even if you're not a student. So but I'll clarify that, and then I can reach out to you and send that to you, probably your email or something.
Okay.
You can
maybe so it would be nice
in
if it can be shared with us. I would appreciate that.
Okay, I'll do that. I'll share in this chat section, so you can after the meeting, you can actually still come back to check the chat. I'll drop it in the chat, and I'll also send it via email also. I don't know if you registered for the event.
Yes, I did.
Okay. So I'll just send it to you. I'll get your email and send it to you.
Okay, thank you.
Yeah. Do we have any more questions? Samuel, you can go ahead.
All right. Sorry. Can you hear me?
Yes, I can.
Okay. So sorry, I just wanted to confirm. You said as a student you have 30 days. I'm sorry, you have $100. Is it till you finish the $100, or you just have 30 days for the $100? Because I can remember mine, even though I had not exhausted the $100, everything just went off after 1 month.
1 month or a year?
Yeah, after 30 days.
Oh, okay. Probably that's I think maybe you ran an experiment and you didn't delete your resources after, so it just kept on charging for the compute that was running. I'll assume that what happened, because
No,
actually
that wasn't what happened. That was actually sent a mail that okay, wait, it's possible that there's difference. Sorry, I used an office mail instead of a student mail, so it was just 30 days. Maybe that's the difference.
Okay. So I think what you just said now answers Kachi's question. So you have 30 months trial and 30 days trial, even if you're not a student. Yes, that was what I was trying to get, but it's skipped my mind. Kachi, I don't know if thank you for your question, Samuel. I mean, you've answered the 2 questions in one, basically. Thank you. So if you're a student, you won't have that issue. It's for a year, and then it's until you finish it. actually. So it doesn't just go like that if you don't use it. But after a year, it clears out. So yeah, Kachi, Samuel indirectly just answered our question. I mean your question. So you have a 30 days trial with Azure for free, even if you're not a student.
Oh, fantastic.
Okay,
Right.
sorry, can I quickly ask one more question?
Yeah, sure.
Okay, so since you're a student ambassador, you probably have access to this. I'm trying to take the certificates for data science, and I'm looking for textbook. Let's put it as textbook because I know there are some textbook which covers everything you need to learn for the data science associates plan. I'm sorry, certificates. Do you have access to such resource?
No, I don't, unfortunately. Right, but most of the time, Microsoft Learn is pretty good enough for you to leverage for most of the certification exams. But I think you mentioned you're taking the associate, not the fundamentals, right?
No, not the fundamentals.
Okay. So I would let you know if I get any information about maybe I assume that you'll be looking for free resources, not something that you necessarily have to pay for, or both are welcome.
Definitely both are welcome. Free will
Okay,
be
yeah, I'll just
preferably, but both are
yes,
welcome.
yeah. All right, I'll get more information on that and get back to you. I don't know if you registered for the event. If you didn't, I'd appreciate if you drop your email in the chat so I can
No,
reach
I
out to you.
registered for the event. I
Okay,
registered.
all right,
All right.
all right.
If you
I'll
see
reach out to you then.
vouchers too, please send it our way. Thank you.
Well, I don't have control over that, but I understand. All right.
All right.
Yeah,
Yeah, thank you.
no problem. You're welcome. So yeah, we're done with this now. So I just want to quickly do the comparison and then we'll end it here. So we can see that the XGBoost here is also the best model along with the Max App Scaler for training without the feature engineered, the engineered feature actually, basically. But if we check the metrics and go over to our confusion matrix, you see that 7 fraud cases, right, were actually predicted as not fraud, which is pretty bad. If you compare it, the total that were fraudulent were 19 here if you're taking it. So if you do a comparison, let's say, let me just quickly head over to my notebook here. If we do 12 divided by 19, which is 12 plus 7, that's only 63% precision. Let me put it that way. Well, it's actually recall. It's 63% recall. But then I'm trying to like compare with the actual fraudulent cases. So we can say the ones that were actually fraud, how well did it predict the ones that were fraudulent? Just by 63% accuracy, we can term it as that, right? Which is, I would say, is bad because you are missing about 37% of fraudulent cases, which, I mean, we are professionals here, and even ourselves we know that it's a huge number. 37% miss is a huge number on fraud cases. So this is one of the advantages of having a background knowledge, maybe in data science or machine learning can help you. So you can see that just that one simple feature, percent in and out, changed this to 0 and made this 19. So we had 100% on predicting the actual fraudulent cases. So yeah, that will be it for these events. Thank you to everyone that has joined in. And like I was trying to explain to someone, it's important that you clear your resources. So once you're done, you can head over to your resource group and delete everything. If you're doing it for experimentation, but if you are still going to make use of the endpoints and everything, you can go ahead to leave it, right? But if you are just doing some experimentation to avoid accumulating charges on your account, you can delete the resource, copy the resource name, and to clear everything here, which of course includes your storage, the Azure Machine Learning Workspace, and other details, right? So Yeah, I just want to show you basically what it looks like. Yeah, so you can just copy this, type in the resource name, and you confirm. So thank you very much to everyone that has joined in. I sincerely appreciate, and I believe that we've gained one or two or added a lot more to our skill set this night. And just before we go, there are some resources that I put here that you can check through to get a better understanding of how Azure works, and other resources you can make use of. So you can take these, you can call them courses or learning paths or modules in Azure, in Microsoft Learn, on how to use AutoML on Azure Machine Learning, create no-code solutions with Azure Machine Learning, compute targets, understanding how they work. And Nuance Gatekeeper is actually a fraud prevention solution that has to do with analyzing phishing, spoofing, and so many other things, right? You can check that out too. You have the anomaly detector service also in Azure that you can use to track credit card fraud, detect anomalies in transactions and all that. So many tools you can leverage on Azure, no code or low code. So you don't need to have so much experience in AI or data science or machine learning. So thank you for joining in. This is the link if you need access to the slides. It will still be shared after the event. Thank you again. Thanks to everyone for joining in. Enjoy the rest of your evening or enjoy the rest of your day. I think Kachi has a question. Okay, before we.
Please, the recorded video meeting, are we going to get it?
Yes, you will. You will.
Okay, thank you.
Sorry.
All right.
Mr. Samuel,
Yes.
sorry, please. The link to sign up for the Azure, please,
Yeah.
can you share it with us?
Yeah. Okay. Let me quickly get that now and send to you. Azure for students. So I'll drop that in the chats now.
Thank you for your time.
Yeah, you're welcome.
And thank you for
And
impacting on us. Thank you.
thank you. I've sent that now, so you have access to it now. So yeah, that will be all. Thanks to everyone. You can come back to check the charts for the slides and other details that you might need, and then you could check your mails too for those that participated in Kahoot for your prizes, and then for others that have also made inquiries about some other things they will need, you also get that. I would post the recording. You would get access to it basically. Reach out to us via emails, and yeah, thank you very much for joining in. I really appreciate it. Enjoy the rest of your day. Bye.